we shall solve a problem on neural tree algorithm. We shall solve the same problem which we have solved using Markov algorithm. So the question is, using neural tree algorithm, solve the following pattern space classification. So we are given this pattern space in which the patterns are indicated. Class 1 patterns are indicated with X, class 2 patterns are indicated with a circle or a 0. So now first we shall be drawing the lines for the nodes of the neural network which will be designed, that is a tree, neural tree. So as you know that in a neural tree algorithm we will be developing a neural network which will be made up of decision nodes, and these decision nodes will form the decision tree. So first we have to ensure that there are minimum number of misclassifications while selecting the first line. So step 1, if at all we proceed, we select line alpha. So where shall we select this line alpha? So I would randomly select this line alpha somewhere here. Now such that if at all you look at this particular line, we have 1 misclassification, 2, 3, 4 misclassifications. You can draw the line anywhere else also, such a way that you find that there are lesser misclassifications. So I have taken this line, first line as alpha, and the direction, as we have seen, the direction we usually take in the direction of class 1. So before that we shall assume that class 1 region output will be high, and say class 2 patterns, or I would say class 1 region, rather than saying class 1 region, I would say class 1 patterns. We are designing a neural network such that for class 1 patterns the output will be high, and for class 2 patterns the output will be low. So the direction should be towards the class 1 patterns. So we have selected the line alpha, and what is the equation of this line alpha? The equation of this line is x1 minus 2.5 is equal to 0, and 0, 0 point is not lying, so we can stick with this equation. Now next is to find out the next equation to separate, that is beta. So in this case, there are some patterns which are not classified. So now we need to go forward with the next line, and I can select the line, say I would select the line here. This is beta, and this is, I say, beta 1, and similarly I need to select another line beta 2 on the other side of the region. So where I would select, say probably I would select, say, here. So both the side of these lines, beta 1 and beta 2, we are getting a complete classification that takes place. So which side? Now first we shall see the direction. Which is the direction of beta 1? Beta 1 direction we take this side, because that side is your class 2, class 1 patterns are maximum, and beta 2 also direction we take this side. Why? Because here there is a class 1 pattern, this side there are no class 1 patterns. So we take this direction. So in the step 2 we have selected line beta 1 and beta 2. So these lines beta 1 and beta 2, what they will do is that, what are the equations for beta 1? Equations for beta 1 is x1 minus 3.5 is equal to 0, and beta 2 equation is x1 minus 1.5 is equal to 0. Now I am going fast because I am not telling you that this point is say 1.5, this point is say 3.5, it is understood. Because we have already solved problems previously, so it is understood that you all know that and how you get the equations for these lines. And again, both the regions are this direction, so that 0, 0 point is not there. So whatever equations you have got are fine enough. Now we move on to the third step, that is step 3. So in step 3 what will happen is that, now what you see is that this alpha 1, what we have done so far is we have developed a neural network such that, I will just draw what we have done so far. We have taken first node alpha, this we have taken first node, and if at all you are going on the positive side of alpha and the negative side of alpha. Now on the positive side of alpha, that is this side, what we have taken is that we have taken beta 1. So this is the second decision node, that is the child node of alpha, and there is beta 2. So this is, if at all alpha the output is 1, then it will go towards beta. If at all the output at alpha is 0, it will go towards beta 2. So at beta 1 and beta 2, again then you can proceed in two directions, this side and this side. Similarly here also you can proceed this side and this side. Now if at all you see towards beta 1, what we see is that towards beta 1, we see that the class, whatever is on the positive side of beta 1, everything is completely classified. So on this side, everything is completely classified and the patterns belong to class 1. But what happens on the other side? It is misclassified. We have this region which is misclassified. So I would require another node at this particular point. Similarly, beta 2, if at all I go on the positive side, this region is misclassified, and if at all you go on the negative side, this region is completely classified, so it belongs to class 2. Okay, so now we move on further. Now in step 3 we need to select 2 more lines such that it will do the classification. On this side, that is on beta 1 side, I take a line here, and the direction which I have to take is, the direction will be below here, because on top it is only class 2 patterns. Similarly on the other side also I can take a line, and I take the same line, if at all I can take the same line, and again here the direction can be the positive direction. Okay, so this direction I can take. So this line will be, say, gamma 1, this line will be gamma 2. So what is the equation of gamma 1? Obviously equation of both gamma 1 and gamma 2 will be the same. So it will be x2 minus 2.5 is equal to 0, and since 0, 0 point is lying in this region because it is down, right? So it will be lying in this region. So we have to change the sign and we get gamma 1. Now I cannot write equal to sign here, I will write a colon. So gamma 1 is nothing but minus x2 plus 2.5 is equal to 0. This is the equation. And similarly we have gamma 2 is also minus x2 plus 2.5 is equal to 0. Now on the negative side of gamma 1 and gamma 2, we see that here everything is properly classified. Okay, so we see that everything is properly classified. Now we move on and draw a node gamma 1 and gamma 2. So where will be gamma 1 and gamma 2? So here will be the node gamma 1 and here will be the node gamma 2. So on the positive side, it is not classified, but on the negative side it is completely classified and it is class 2. Similarly, I write for this also. Negative side it is completely classified, it is class 2, and positive side it is not classified. So now this positive side we will have to select one more line that will be coming in step 4, and obviously you can, as seen here, you can select the same line. So here I can take this line. So So I name this line as delta 1, and also I need one more line here for the other side. That line will be also named as delta 2. But if at all you see, both the equations are the same for both these lines. So where will this delta 1 come? Delta 1 will come here. And if at all you go on the positive side of delta 1, it will be class 1. And if at all you go on the negative side, it will be class 2. And here also, there will be this delta 2. If at all you go on positive side, it will be again class 1. If at all you go on negative side, again it will be class 2. So this is the neural tree which we have designed. It is not done. We have not yet written the equations for delta 1 and delta 2. So what are the equations for delta 1 and delta 2? The equations for delta 1 and delta 2 in step 4, which we are getting. So delta 1, both equations will be same. That is x2 minus 1.5 is equal to 0. And 0, 0 is not lying in this region because it is going upwards, and delta 2 is x minus 1.5 is equal to 0. See, if at all you are drawing lines parallel to the x-axis, parallel to the y-axis, in our case x1 axis and x2 axis respectively, then the sign changes you can make out very easily. Okay, if at all I write the equation, and only if at all they are not in the positive direction, then you have to change the sign. Say for example, we had only one case where gamma 1 and gamma 2, it was in the downward direction. That time we have to change the sign. If it is in the upward direction, you don't have to change the sign. Similarly, if it is in the from left to right, you don't have to change the sign. If it is from right to left, then you have to change. So we can perform the classification of the patterns using this particular neural network which we have got, but only thing is that now we have to write the nodes depending upon the equations which we have got. So first equation we have to write for alpha and alpha node. So I will draw the alpha node and with the weights. Now alpha node equation was, so alpha equation is x1 minus 2.5 is equal to 0. So I get this particular network. Then I get beta 1 and beta 2. So beta 1 node. So what is beta 1 equation? Beta 1 equation is x1 minus 3.5 is equal to 0. And beta 2 equation is x1 minus 1.5 is equal to 0. So I can draw the nodes, that is beta 1 node and beta 2 nodes. So for this one, the weight is this, and here the weight is minus 3.5. So similarly now I can go in for gamma 1 and gamma 2 nodes. So for gamma 1 and gamma 2 nodes, so gamma 1 node, so gamma 1, the equation, the same equation is for gamma 2 also. So I will write for gamma 1, gamma 2 equations are same, that is minus x2 plus 2.5 is equal to 0. So see, this particular problem you can solve it in a different way. Everybody can solve it in a different way. Every time I solve also, I may solve it in a different way. It is not, there is no, it need not be the same. But only thing is that you should perform the classification task. So this is O gamma 1, this is O gamma 2. Now we are left with only the last node, two nodes, that is delta 1 and delta 2 nodes. So again both the nodes are same because the equations for delta 1, this is gamma 2 node, this is beta 2 node. So delta 2 node, now what is equation for delta 1 and delta 2? It is the same thing, minus x, sorry, plus x2 minus x2 minus 1.5 is equal to 0. So I can just draw this node as well. So only in this particular main neural network we have not yet indicated the inputs, which we will be showing here. Inputs, and these inputs have to go to each and every from here. When the same inputs are going here, I will just draw one line rather than showing many lines. So the inputs will be going to each of these nodes as shown by the yellow arrows. So we have solved this particular network, the classification problem, by using this neural network. So you all can solve more problems for practice using neural tree algorithm.